The language of hypothesis testing. This should be pretty simple, so let's focus in. So let's formulate a null and alternate hypothesis. And actually, that's the wrong definition for the slide. We should be defining what they are. So a hypothesis is a claim about a population characteristic. And a null hypothesis is a status quo. That just means we assume it's true unless proven otherwise. Um, the alternative hypothesis is the burden of proof to disprove the null hypothesis. So all that means is that in a court case, the null is innocent because the null hypothesis is that the person didn't commit a crime, and it's the prosecution's role to try to accuse the guy of a crime and have the jury decide whether he's guilty or not. But we assume that the guy's innocent at first, which is why that kind of relates to the null hypothesis. So there are three types of tests. There's a two-tailed test, which is when you basically just check if two values are not equal to each other. So if we assume that the status quo is that the two population means are the same, then a two-tailed test would be if they're not the same. A left-tailed test is if we check that the population mean is smaller than the other mean. A right-tailed test is if we see the value is more. Here is an example using candy. So there are two types of mistakes when doing a hypothesis test. Type 1 is rejecting the null hypothesis when it's actually right. Type 2 is failing to reject the null hypothesis, finding that the alternative hypothesis is correct. So the alpha sign is kind of like a confidence interval. No, it's not a confidence interval. It's the probability of a type 1 error. Oh no, it's the complement of the confidence interval. No, it is the confidence interval, but in probability instead of standard deviations. So the beta sign is the probability of a type 2 error, which is just 1 minus alpha. So alpha is the probability of a type 1 error, beta is the probability of a type 2 error. So an alpha of 0.05 is sufficient evidence, but this isn't always consistent. An alpha of 0.9, sorry, an alpha of, I think that was wrong. An alpha of 0.03 will likely be sufficient in a murder case because, or sorry, an alpha of an alpha of 0.03 would probably be for a murder case because we would assume, and we would have to take this into higher stakes. We can't have a higher chance that we'd be wrong. So the beta is set, and since the power is 1 minus beta, both are not fixed. So beta and alpha can vary depending on each other. So you never prove anything in statistics because nothing is actually true. It's just basically what evidence supports. So if we reject the null hypothesis, we say there's not sufficient there's sufficient evidence to support the alternative hypothesis, and vice versa. If we don't reject it, we say there is not sufficient evidence. We never prove anything since everything is based off probabilities, not certainties, and that's the language of hypothesis testing.